This is Nagurskoye Air Base, 80 degrees north on the frozen edge of Franz Josef Land, the northernmost military airfield on Earth. Its 2,500-meter runway cuts through permafrost, layered with concrete slabs and refrigeration coils that stop the ground from melting. Here, MiG-41 BM interceptors take off in -50-degree blizzards, armed with R-37M long-range missiles that can hit targets 300 kilometers away, aircraft, cruise missiles, even low-orbit satellites. Russia has reactivated or built over 50 Arctic installations since 2014. That includes 13 airfields, 10 radar complexes, and dozens of logistical hubs, each hardened against months of darkness, hurricane-force winds, and ice buildup over a meter thick. On Kotelny Island, two Tu-142 bombers and Il-78 tankers patrol the northern sea route, while Tixi Air Base fields Su-35 S-fighters with ranges beyond 3,600 kilometers, extending Arctic patrols deep into the polar night. Beneath this network lies one of the world's largest untapped reserves. The U.S. Geological Survey estimates 13% of global undiscovered oil and 30% of its natural gas lie under the Arctic Ocean. As the ice retreats, the northern sea route stays open for nearly half the year, cutting 40% off the distance between Asia and Europe. For Moscow, control of the Arctic means control of the world's shortest trade line. The region is also the shortest path between Russia and North America. Borei-a submarines armed with R-30 Bulava missiles patrol beneath the ice, while S-400 and S-500 systems guard the skies up to 600 kilometers out and 200 kilometers high. All feed data into the Northern Fleet's unified command chain, a digital shield across the pole. Even supply lines look futuristic. Arctica-class nuclear icebreakers, Project 22220, weighing 33,500 tons and powered by twin RITM-200 reactors, cut through 3-meter-thick ice to reach the bases. Every radar, hangar, and module is airlifted by Il-76 MD-90A transports and assembled on site, piece by piece, empire by empire. The total cost of Russia's Arctic expansion since 2014 is estimated between $1.5 billion and $2 billion, covering construction, logistics, and energy infrastructure, from airfield heating systems to compact nuclear power plants like Akademik Lomonosov, a floating reactor providing electricity to coastal bases. From orbit, these facilities look like bright dots on an empty white canvas. But those dots are alive, transmitting, tracking, and waiting. Beneath the silence of the snow, Russia has built a command network where every runway is a launch point, every dome an eye, and every frozen island a weapon. The Arctic is no longer a frontier, it's a front line. Welcome to military power. Today we're diving deep into what really stands behind Russia's Arctic military program, the bases, the missiles, and the cold logic shaping the top of the world. Russia's Arctic defenses now operate as a layered ecosystem, one built from numbers as much as from metal. At the heart of it sits the S-500 Prometey, a missile shield capable of tracking targets up to 600 kilometers away and at altitudes exceeding 200 kilometers, essentially grazing the edge of space. Its radar network can lock onto 10 simultaneous threats, aircraft, cruise missiles, or even low-orbit satellites, moving as fast as 7 kilometers per second, roughly Mach 20. Reaction time from radar acquisition to launch is measured in mere seconds, often 3 to 4, turning early warning into instant retaliation. Each S-500 battery, mounted on massive 10x10 BAZ-69096 trucks, moves across frozen tundra, where no paved roads exist, creating a fluid perimeter. A single unit costs roughly $600 to $700 million, similar to an American THAAD system, and consumes up to 50 tons of fuel and supplies per week to maintain Arctic readiness. When deployed at sites like Tixi or Kotelny Island, these batteries form overlapping coverage arcs that seal airspace from the Barents Sea to the Laptov frontier, a span of nearly 2,500 kilometers. Feeding these radars are the Voronezh DM early warning arrays, gigantic phased panels, each nearly 30 meters high, able to scan 6,000 kilometers across the horizon. One radar in Olenogorsk can track launches from Greenland, while another in Pechora monitors the polar corridor toward North America. Combined, they form a near-continuous detection net stretching over half the Arctic Circle, linked by hardened fiber and satellite relays that remain functional even in magnetic storms. But the shield alone means nothing without the sword. The MiG-41BM interceptors stationed at Nagurskoye and Rogachevo fill that role. Each Foxhound, with twin D-30F6 engines generating 152 kilonewtons of thrust, can reach speeds up to 3,000 kilometers per hour and operate above 20,000 meters, high enough to meet ballistic targets mid-arc. Armed with R-37M air-to-air missiles capable of 300-kilometer engagements, a single MiG-31 patrol can guard airspace roughly the size of France. The MiG-31K variant, armed with the Kh-47M2 Kinjal, extends that deterrence far beyond, a 2,000-kilometer strike envelope at speeds up to Mach 10, which is 12,000 kilometers per hour. Launched from Arctic bases, that reach covers the Norwegian Sea, Greenland's coast, or even parts of Alaska. Supporting them are Su-34 fullbacks, twin-seat strike aircraft built for endurance. With internal fuel exceeding 12 tons, a combat radius of around 1,400 kilometers, and payloads reaching 8,000 kilograms, they can deliver cruise missiles like the Kh-59 Mk2 or anti-ship Kh-31AD. Their onboard radar, the Shaoan-41, can track 10 targets simultaneously and engage 4 at once, even in snow-blind conditions. Flying from Tixi or Temp Airfield, Su-34s can cover the Northern Sea Route, a corridor spanning 5,600 kilometers, within a single mission, protecting shipping convoys or striking intruders long before they threaten coastal hubs. This integrated system forms what Russian planners call active Arctic defense, a multi-layered architecture combining radar arrays, interceptor aircraft, and missile batteries into one continuous grid. A typical engagement chain begins when a Voronezh radar detects a target 5,000 kilometers away. Within seconds, an S-500 battery receives target vectors, and within 4 to 6 minutes, a MiG-31 pair is airborne to verify and intercept. The Su-34s remain on standby to engage any surface vessels or radar signatures detected along the route. In essence, Russia's Arctic is not defended linearly, it's defended volumetrically. Operating in this frozen chessboard isn't free. The S-500's electronics must withstand minus 50 degrees Celsius. MiG-31 hydraulic systems require specialized synthetic lubricants that cost 10 times more than standard aviation fluids. A single Arctic sortie can burn 16 tons of jet fuel, and keeping a base operational through the winter consumes 5,000 tons of diesel for generators. Russia's fleet of Project 22220 Arctica icebreakers, each displacing 33,500 tons and powered by 2 RITM-200 reactors producing 175 megawatts, ensures supply convoys break through ice 3 meters thick. Every base, missile, and airframe depends on this floating logistics chain. That's why the MiG-41 matters. Officially the PAKDP, it promises Mach 4.3 speed, altitudes above 25,000 meters, and a potential 450-kilometer interception range. Unlike the MiG-31, it's being engineered with hybrid turbo-ramjet engines and heat-resistant composites rated to 450 degrees Celsius. If completed, it won't just patrol the Arctic, it will dominate it, intercepting hypersonic glide vehicles, near-space drones, and even low-orbit satellites. Rumors suggest an unmanned variant with onboard AI derived from the Su-57's electronic co-pilot suite. For now, it's a promise. But when the prototype rolls out, and if it ever takes its place at Nagurskoye, the Arctic will stop being a buffer and become a trigger line. Because when a jet flies faster than 5,000 kilometers per hour in minus 50 degrees Celsius air, armed with missiles that can hit before radar warnings finish blinking, the next Cold War won't just be cold, it'll be frozen solid. For comparison, NATO's Arctic presence looks smaller but broader. The United States has over 100 fifth-generation fighters stationed in Alaska alone, mainly F-22s and F-35s, with combat reach over 1,800 kilometers. Canada's NORAD modernization, a $38.6 billion project, will add radar coverage out to 3,000 kilometers, while Norway's P-8A Poseidon Patrol aircraft can scan 2 million square kilometers of ocean per mission. Yet, none of these bases sit as close to the pole as Russia's network. Most are 1,000 kilometers farther south, meaning Russia's fighters and missiles get first look, first lock, and first launch. Canada has awakened from its frozen slumber. Over $38 billion are being poured into NORAD's modernization. New over-the-horizon radar chains stretching from Yukon to Labrador, able to detect cruise missiles and hypersonic gliders flying over 7 kilometers per second. By 2030, these radars will be fully integrated with U.S. early warning satellites, creating the first seamless polar shield between the two countries. What the old DEW line couldn't see, this new digital curtain will. Norway is NATO's spearhead. Its Globus 3 radar in Vardo peers across the Barents Sea just 50 kilometers from Russia's Kola Peninsula, tracking every launch and aircraft movement. Nagurskoye Air Station hosts long-endurance MQ-9B drones scanning up to 2,000 kilometers per sortie, while Evenes Air Base houses P-8A, Poseidon patrol planes watching the deep Arctic for submarines. Each fjord, each inlet, now hides listening posts and underwater sensors designed to detect Russian movement before it surfaces. Farther west, the United States has turned Alaska into the world's most heavily armed piece of tundra. Over 100 F-22s and F-35s operate from Eielson and Elmendorf, covering the polar cap in under 20 minutes. These stealth squadrons can fly in minus 50 degrees Celsius conditions, refuel midair, and engage targets thousands of kilometers from home. At Patuxent Space Base in Greenland, formerly Thule, upgraded phased array radars now track ballistic and hypersonic threats across 4,800 kilometers, feeding into the U.S. Space Command's network. Denmark quietly plays its hand through Greenland, running satellite relays, early warning outposts, and maintenance for American radar installations. Without those Danish sites, NATO's Arctic picture would flicker to black. And then there's China, the scientific player with strategic ambitions. Its icebreaker Zhulong 2 plows through 1.5-meter ice at 15 kilometers per hour, carrying sensors and drones that could double as recon gear. Beijing's investments in Russian Arctic LNG and ports give it leverage, and a foothold in a region where it doesn't even touch the map. This is no longer exploration, it's escalation. The U.S. is fielding new polar security cutters, each costing over $1.2 billion and built to smash 3-meter ice sheets. NATO's Arctic training exercises now involve 40,000 troops, simulating large-scale defense against Russian incursions. Satellites, drones, and undersea cables form the digital nervous system of a new front line that's both invisible and icebound. The real question isn't who owns the Arctic, it's who can afford to keep it. Every runway costs hundreds of millions. Every icebreaker burns 200 tons of fuel per day. Every radar mast must survive winds over 150 kilometers per hour. And yet, they keep building, because whoever controls the top of the planet controls everything that passes beneath it. Hit like, smash subscribe, and stay tuned, because the next great power race isn't in space. It's frozen beneath our feet.